Mr. Singh gives his students a test each week. Anish scores on the first 6 tests. These scores, what was the average? So, as always, you just add them up and divide by the number of tests, which is 6. So, when you add them all up, it's 90, and you divide by 6, and that is 15. John scored 17 and 12 on his first 2 tests. After the third test, his average was 14. What was the score on the third test? So 17 plus 12 plus the third test, which we will call x, divided by 3, they're saying is 14. So you just solve this equation, and when you do, it's 29 plus x, cross-multiply to get 42, and solve to get 13. So 13 was his score on the third test. After the first 6 tests, Dinah had a average test score of 14. On each of the next n tests, Dinah scores 20 out of 20. After all of these tests, her average test was 18. Determine the value of n. So the sum of everything over the number of tests, which in her case I believe is 6, is 14, at least the first part of the question. And then, so this sum basically is 84 if you cross multiply. And then what they're saying is that you have a whole bunch of other tests, that there's n of them, and she gets 20 on all of them. So now the total sum is that 84 plus 20 times n. And then you divide by the total number of tests, which would be 6 plus n. The first 6 and then the n tests after that. And they're saying that is something, I think they told us that, right? It's 18. Okay, there you go. So that's the equation you would have to solve. So let's solve that. This is going to be 84 plus 20n is 108 plus 18n. So that's 2n is 24, and therefore n is 12. So there was 12 additional tests that she took. Each day, Jessica drives from Bowtown to Aville, a distance of 120 kilometers. During the drive, her car's navigation system constantly updates the estimated time of arrival at Aville. The car predicts the ETA by assuming that Jessica will drive the remaining distance at 80 kilometers an hour. On Monday, Jessica drove 90 kilometers an hour. How many minutes did it take Jessica to drive from Bowtown to Aville? Okay, well, the formula throughout this question is speed is equal to distance over time, or any variant of that. So in this case, let's see, speed is 90, and then the distance is 120, and the time is what we're figuring out. And when you do this, this is going to be 120 over 90, which is, well, it's 1.33 repeat, but you remember the hour, it's in hours, so that's, if you convert it to minutes, it'd be 1 hour and 20 minutes. So that takes care of part A. Part B, on Tuesday, Jessica left Bowtown at 7 a.m. What was the ETA displayed by her car at 7 a.m.? Okay, again, speed is equal to distance over time. So in this case, the ETA is calculated, as the question says, for a speed of 80. So we're going to put 80 there. And then the distance is 120, as we previously figured out. Or actually, was that given in the question? Yeah, it's given in the question. Well, I didn't figure it out. Okay, so that goes there. And then that t we'll figure out. So t is going to be 1.5, which is 1 hour and 30 minutes, right? Yeah, 30 minutes. So at 7 a.m., the ETA would basically be this plus 7 a.m. plus this 1 hour and 30 minutes, which is 8:30 a.m. So that's pretty much how you would do part B. On Tuesday, Jessica drove at 90 kilometers an hour. Determine the ETA displayed by her car at 7:16. So same kind of story, I guess. So from 7 a.m. to 7:16 a.m., she is driving at 90 kilometers an hour. Okay. So again, speed is equal to distance over time, that same formula. So that speed is 90, that distance. Well, the distance I don't know. The time is the 16 minutes, so that's 16 over 60 in terms of hours. So when you solve this, you get d equal to 24. So that means that she's driven 24 kilometers of the 120. So of the 120, she's driven 24, so that means there's 96 kilometers remaining. Okay. So I guess we have to do this for 96 now. The same kind of story. So speed, again, she's going to be driving at... but now we have to figure out the ETA. The ETA is calculated with the speed of 80, if you remember the question stem. So distance over time, the distance is 96, and the time, I got it. Okay, so this is going to be 1.2. So that is 1 hour and what's that, 12 minutes, I think. So then you add that to the 716. So that's going to be 8:28, I believe, 8:28 a.m. On Wednesday, Jessica noted the ETA predicted by her car when she left Bowtown. She traveled the first part of the trip at 50 kilometers an hour and traveled the rest of the way at 100. Jessica arrived in Aville at the ETA predicted by her car when she left Bowtown, determined the distance that she drove at the speed of 100. All right, so let's explain this question here. We got Bowtown here. We have Aville there. And then for part of the way, she drives at 50 kilometers an hour, and the remaining way she drives at 100. And since the total distance is 120, this is going to be 120 minus x. Yeah. Okay, so then at 7 a.m. she sets off, I believe. Is it 7 a.m.? Is there anything? Oh, we're continuing Wednesday, right? Wednesday, where's Wednesday? When she left Bowtown, blah, blah, blah. Well, it doesn't really matter. We can just use 7 a.m. as an example because we just need to kind of figure this out. So let's just say she left at 7 a.m. And then the ETA, we find out with a speed of 80 according to the question. So speed is equal to distance over time. Speed is 80 and distance is 120. And when you solve for this, you get t equal to 1.5, which is 90 minutes. So we add that to the 7 a.m. So that means the ETA is 8:30. So that's pretty much the ETA calculation. Pretty straightforward. And then now we're given a couple other things. We have two scenarios here. We have this first scenario that travels at 50 and then 100. So we're going to have two times. We're going to take that speed equals distance over time formula and modify it to make it t is equal to d over s. And then we're going to have two times t1 and t2. T1 is this distance here. So that's going to be distance, which is x over speed. And t2 is 120 minus x over 100. Got it? And when you add these two, it's got to equal this 90 minutes. Because remember, the ETA's got to match. That's pretty much what this question is saying. So that means that t1 plus t2 has got to equal that 9, or actually it's going to be in hours, right? So 1.5. We just got to make sure the units are the same. Okay, so now let's plug in those formulas. X over 50 plus 120 minus x over 100 is 1.5. And then now we just have to solve this algebra. So this will be 2x plus 120 minus x over 100 is equal to 1.5. That'll be x plus 120, and then this will be 150. So I believe x is 30. Oh, wait, hold on. X is 30. Yeah, x is 30. And what are they asking for again? Determine the distance that she drove at the speed of 100. So that's this guy. Okay. So 120 minus x is really what the question is asking. So 120 minus 30 is what we want, and therefore 90. So 90 kilometers is the answer to this question. A sequence of t1, t2, t3 is defined by t1 is equal to 1, t2 is equal to 2, and each term after the second is equal to 1 more than the product of all the previous terms in the sequence. That is, tn plus 1 is 1 plus t1 times t2 all the way to tn for all integers n greater than or equal to 2. For example, t3 is equal to 1 and t1, t2 T3 is equal to 1 plus T1 times T2, which is 3. What is the value of T5? Okay, so let's go through this here. Let's calculate this guy. So T1 is 1, right? They gave me that there. T2 is 2. Okay, great. So T3, according to their formula, would be 1 plus T1 times T2. So that is 3. And they already gave you that one. So let's just keep going. T4 would be 1 plus T1 times T2 times T3, which looks to me like 7. T5 is going to be 1 plus T1 times T2 times T3 times T4, which looks to me like 6 times 7 is 42. 42 plus 1, 43. And so on. Let's just do one more. T3 is 1 plus T1 times T2 times T3, T4, T5, and this is going to be 1807. Okay, so what do they want? They want a T5, right? So T5 is 43. Okay, so that takes care of that guy. All right, now we're going to get into some proofs here. Prove this right here, that Tn plus 1 is equal to Tn squared minus Tn plus 1. Okay. We can use the left side, right side type of notation. So Tn plus 1 is equal to Tn squared minus Tn plus 1. This is what we're trying to prove. So the left side is equal to Tn plus 1. Okay, great. Now let's talk about the right side. Now this right side, well, actually, let's concentrate on the left side. So let's just concentrate on this guy here. Tn plus 1, by definition, would be 1 plus T1 times T2 all the way till Tn, right? Yeah. Actually, let's put in a Tn minus 1 and then Tn. So that's just by definition, which is what they gave up here, up there. Okay, so this guy, I'm going to modify this a little bit. Sort of group those ones together like that. Now this right here, by definition, is Tn, I believe, but without the 1, Tn minus 1. Yeah, basically by definition. And then you just multiply this out. So this becomes Tn squared minus Tn. And this is the exact same as this guy, which is the right side. Just rearranged a little bit. And I think that's it. That completes the proof. So, not so bad. Prove that Tn. Part C. Prove that Tn plus Tn plus 1 is a factor of Tn times Tn plus 1 minus 1. Basically what they're asking is that we have to show that this Tn times Tn plus 1 minus 1 can be written as Tn plus 1 times something. So this is essentially a factor of this whole thing. Okay? Well, the good news is we can use what we've already proved up here. So that Tn plus 1 is equal to Tn squared minus Tn plus 1. So what we're going to do is sub that into here. So we have Tn, and instead of Tn plus 1, we're going to put in that Tn squared minus Tn plus 1. And then we have that minus 1. So that's all I did was for this guy, I just substituted that. Okay, now let's expand this. When you expand this, you get a Tn to the power of 3 minus Tn squared plus Tn minus 1. Okay. And then I think we can factor here. We can take out a Tn squared, and that leaves Tn minus 1. And this is Tn minus 1. So then this factors very nicely into Tn minus 1 times Tn squared plus 1. Correct? Yeah. Okay. So where do I go from here? And let's just put the other part. This was Tn times Tn plus 1 minus 1. Okay. Let's see here. Okay, I got it. So we now just have to use this guy. if you modified that, you would actually get, if you bring the Tn over, you would get Tn plus 1 plus Tn. And on the other side, you'd get this Tn squared plus 1. So instead of this, you put in that. So then you'd have Tn minus 1 times Tn plus 1 plus Tn. And there you go. We just showed that that's a factor of this guy, which is exactly what I was trying to show up there. Okay, so Tn plus 1 is a factor of Tn times Tn plus 1 minus 1. Prove that T218 is not a perfect square. Again, from our part B, we have proven the following, that Tn plus 1 is equal to Tn squared minus Tn plus 1, correct? So that means that T, if you're going to use 2018, would be T 2017 squared minus T 2017 plus 1, right? If you used n equal to 2017. So that means that if we rearrange this formula, that T 2017 squared, that guy, let's just write it over here, T 2017 squared is equal to, well, you understand that if you looked at this, T 2017 squared is obviously a very, very large number. So it's going to be greater than T 2017 squared minus T 2017. I think most people would agree, because this is going to be a positive number, right? And you can tack on that one. That one won't make much of a difference, because T 2017 squared is so huge that we could pretty be confident that this inequality still holds valid. Okay. And then we can continue this inequality. You can write the same kind of thing. Let me just write it again. 17 squared minus T 2017 plus 1. And then you can subtract another T 2017. That, you know, you might say, well, why did you do that? Well, it'll become clear very soon, but at least you can be confident that this inequality still holds true. So then you just keep going here, just write this again. This guy in the middle, T 2017 squared minus T 2017 plus 1. Now this guy here factors. If you collect like terms, it'll factor. It'll basically be T 2017 squared minus 2 T 2017 plus 1, and that factors nicely. T 2017, T 2017, minus 1, I believe. Minus 1. Yeah, like that. Okay, so that's pretty good. So that means that T 2017 squared is greater than this guy, T 2017 squared minus T 2017 plus 1. And this is just T 2017 minus 1 all squared. Okay, so we're getting somewhere. Now, this is 2017 squared. That doesn't change. This, actually, by definition, is T 2018, right? You can look up the definition up here. That's pretty much what we have. And then that's greater than this guy, which is the same thing for now. 2017 minus 1. The only thing we can say is it's a perfect square, and this is a perfect square. So that means that these two terms are two consecutive perfect squares. Let me just write all that out first. So we can conclude that since this guy is a perfect square, and that's a perfect square, obviously, and they're consecutive perfect squares, right? T 2017 minus 1 is an integer, and then the very next integer, if you add 1, would be T 2017. So since they're consecutive perfect squares, and this lies in between them, it cannot possibly be a perfect square. So that is basically the proof for 3D. Consider the two parabolas defined by the equation y is equal to x squared minus 8x plus 17 and y is equal to minus x squared plus 4x plus 7. Determine the coordinates of the vertices v1 and v2 of these parabolas. All right, so we have y is equal to x squared minus 8x plus 17. I just do it by completing the square. So you take this coefficient, which is minus 8x, take half of it, which would be minus 4, and then square it to get 16. So that's how you complete the square. So you add it, and then you immediately subtract it. And what that does is allows you to factor those three terms very nicely. And in this case, it would be x minus 4 squared. And then don't forget about that. That needs to be put in. Now what this does is it gives you the vertex. The vertex is, like if you wrote it, it's in another form. That's basically the form that tells you what the vertex is, and vertex is HK. So if you look at that guy, the vertex would be minus 4, 1. Yeah. So that is your V1. And then, of course, they want us to figure out V2. So did they give us? Yeah, they give us another one. So same story. And of course, you can do this by yourself. But the first thing you need to have is you need to factor out that minus 1. So, okay, so now we can do it. So take that coefficient, which is minus 4, take half of it, minus 2, and then square it, so positive 4. So we have minus x squared minus 4x, and then add 4, and then minus 4. And then don't forget about that minus 7. And then this guy, right, these three terms factor very nicely. I believe it's x minus 2 all squared, and then these guys would be minus 11, but when you kick it out of the bracket, it becomes plus 11. So again, we got it in this form, and therefore the HK in this case is minus 2, sorry, the HK in this case is 211, yeah, 211. So that is my V2. So, I guess let's really quickly just like to draw them. Sorry, I think this is 4-1. I don't know why I put the minus there. Sorry about that. 4-1. So the vertex is 4-1. We know that if this is approximately 4-1, then this coefficient here is 1, so it's going to open upwards. So this is sort of like what it looks like. Yeah. And then this guy, same thing, 211. So this is 2 and this is 11. But this is negative 1, so it's going to open downwards, so it's going to be something like this. So very, very quick sketch of those two. Suppose that these two parabolas intersect at points P and Q. Explain why the quadrilateral VP V2Q is a parallelogram. Okay. So, first thing we need to do is figure out what are the coordinates. So I'm going to set those two equal to each other to figure out their intersection points. Plus 4x and plus 7. So let's put everything on one side. 2x squared minus 12x plus 10 is 0. Divide through by 2, we get x squared minus 6x plus 5 is 0. And this factors very nicely. X, 5, 1, minus, minus. So x is either 1 or 5. And we can substitute these values back into any of these to get the y coordinates. So when you do, you get 10 and 2, I believe. So we take those 4 points and we plot them, and we get approximately what we're hoping is a parallelogram or quadrilateral, whatever. So we have to prove that. So how do we prove that this is a quadrilateral? Well, we have to prove that it's a parallelogram, and we do that if, well, there's a few ways, but if we can prove that the diagonals bisect each other, then that should be sufficient. So let's see. Let's see if the diagonals bisect each other. Okay, so how do we do that? The first diagonal will be V1 to V2. And well, let's just figure out the midpoint. If we can figure out the midpoint, that will help us. So that's going to be 4 plus 2 over 2 and 1 plus 11 over 2. And that's 3, 6. And the next diagonal is PQ. And let's figure out the midpoint of that. And that is going to be 1 plus 5 over 2 and 10 plus 2 over 2. And that's going to be 3, 6. So since the midpoints are the same, the diagonals bisect each other. So since midpoints are the same, the diagonals bisect each other. And that pretty much completes that one. Parabolas defined by the equations y is equal to minus x squared plus bx plus c and y is equal to x squared have vertices v3 and v4 respectively for some values of b and c. These parabolas intersect at r and s. Determine all pairs bc for which the points rs exist and the points v3, v4, rs are distinct. We have two parabolas, y is equal to minus x squared plus bx plus c, and we have y is equal to x squared. So, same kind of thing. We need to figure out the vertex. So, complete the square here. Minus bx minus c. Take half of that and square it. So, half of minus b is b over, well, I got minus b. Half of that is minus b over 2. And if you square it, it becomes b squared over 4. So, we got to add that and subtract that. So, add it and then subtract it. And then these three guys should factor. So it's going to be minus x minus b over 2 squared. And then it's going to be plus b squared over 4 plus c. So that means the vertex is b over 2 b squared over 4 plus c. And that's my v3. And then here, this vertex, well, this is just y is equal to x squared, which is like that. So this vertex is just 0, 0. So v4 is 0, 0. That's pretty straightforward. Okay, so now what? Now we have been told that we want all of these guys to be distinct. Okay. So first we have to figure out what are the intersection points, because the intersection points are defined as R and S. Okay. So set these equal to each other to find the intersection point. So x squared is equal to minus x squared plus bx plus c. Okay, now let's solve for this. Let's put everything on one side, and when you do, you get 2x squared minus bx minus c is equal to 0. I think this is going to need a quadratic, so x will be minus b plus or minus the square root of b squared. In this case, it's minus b minus 4ac. all over 2a. So in this case, it's that. You guys are familiar with the quadratic formula, right? So when you simplify this, this becomes x is equal to b plus or minus b squared plus 8c all over 4. And one of these is r and one of these is s. So you need two roots that are distinct. That's what they're saying, distinct here. So the only way that you're going to have two roots is if the discriminant is greater than 0. You guys remember the discriminant, right? Discriminant. The discriminant is what's underneath the square root sign. So b squared minus 4ac. In our case, it's b squared plus 8c when we did our calculation. So that's got to be greater than 0. Okay? So that means that 8c is greater than minus b squared, and therefore c is greater than minus b squared over 8. C is greater than minus b squared over 8. Okay, that's our first condition. So we keep that first condition in mind. Okay, so where do we go from here? Well, we need our r and our s. So one of these guys is r. So which one do you want to make r? I don't think it really matters. One of these is r. So r is b plus b squared plus 8c all over 4. And the other guy we can make s. So s is b minus b squared plus 8c over 4 square root. So you have to make sure that they're distinct. Now, if they're not distinct, then they could be equal to one another. So we had, now actually this is the x coordinate. So this is actually x1. It's not really accurate to say that's s, because s is a point. So these are really the x coordinates of r and s. So I got to make sure I make that distinction. So they're all distinct. So that means that this guy is different to this guy, is different to this guy, is different to this guy. Because remember, that's the whole point. They're saying that they're all distinct. So we have to make sure, if they're all distinct, that they do not equal each other. So that's how we have to figure out another condition. Okay, so let's see what happens here. So they cannot equal each other. So what comparison do you want to make first? I can make this comparison with 0. These guys with 0. So b plus or minus b squared plus 8c all over 4 cannot equal 0. That's the first thing. That's the first comparison I'll make. And let's see here, if I multiply through, this becomes b squared plus 8c becomes 0. And then b equals plus or minus b squared plus 8c. Take the square root, b squared is b squared plus 8c. And therefore 8c is 0. And therefore c cannot be 0. Okay, so that's my other condition. Is there anything else I'm supposed to do here? I think that's it. And then, oh yeah, you got to compare the other ones. You got to make sure that this doesn't equal this. I'll let you guys do that. You come up with the same result, actually. And also that this doesn't equal that. Yeah. So you guys can do that. And you come up with the same conditions, that c has to be greater than minus b squared over 8, and c cannot be 0. And if that is the case, then v3, v4, r, and s are distinct. Final part. Determine all pairs BC for which points R and S exist. The points V3, V4, R, and S are distinct, and quadrilateral V3R, V4S is a rectangle. So very similar to the previous question, but then we've got this extra condition. Okay, so we already proved that to be distinct, we have two conditions that we came up with, and that was that C has to be greater than B squared over 8, and C cannot be equal to 0. Okay. So that's our first part. Now we want to make this a rectangle. No, it's a rectangle if two things. The first thing is that it has to be a parallelogram. And also, because it's a rectangle, at least one pair of adjacent sides are perpendicular. These are the two conditions we've got to solve or prove or whatever. That the diagonals bisect each other, which will prove it's a parallelogram, and that at least one pair of adjacent sides are perpendicular, and that will prove that it's a rectangle. Okay, so let's first start with this guy here. Okay, so parabolas intersect. We have R and S, right? And we've got to give them some coordinates. So I'll call this x1. And the equations are the same, right? Yeah, these equations are the same. Now these two parabolas intersect. Now the first parabola, y equals x squared, that's easy. The second parabola, I don't know what it looks like, but I'm just gonna guess that it kind of looks like something like this since it points down. So both have intersection. They both have intersections, right? There's an intersection point here, and the intersection point there. Now, both of those, for example, if this is r and that's s, both of them lie on y equals x squared. So their points will satisfy that equation. So if I call that r x1, y1, I can actually write it as x1 squared, since y is equal to x squared. You got it? So same thing with s1. If I call this x2 and y2, I can really call it x2 squared. So, okay, so now we got to show this whole thing that diagonals bisect each other. Okay. Well, first we have to do a little bit of analysis of the coordinates of intersection. So we have that first equation, and it equals that. That's the intersection points. So put everything on one side, and you'll get 2x squared minus bx minus c. Now, you guys may remember a special formula called Vietas, and that's what we have to use in this question. Vietas says that if you have an equation of the form ax squared plus bx plus c is 0, that the sum of the roots of that equation can be written as minus b over a. And the product of the roots can be written as c over a. So if we take this equation and apply Vietas, the sum of the roots would be, what would it be? B over 2, I believe. So that would be x1. X1 plus x2. Since we have, those are our roots, basically, our x coordinates. And then the product of the roots, according to the Vietas, if we apply it to that equation, would be c over a, would be minus c over 2, I believe. Minus c over 2, and that's basically the equivalent of x1 times x2. Okay? So we'll use that later on, but that's definitely going to be very important. Okay, so just as before, to figure out this thing, the diagonals bisect each other, we have to look at the midpoints. So the midpoint of v3, v4, we had the coordinates before, right? Let's see here. Let me just write them down just in case you forgot. So it's b over 2 and then b squared over 4 plus c for v3, and then v4 was 0, 0. So the midpoint of v3, v4 is just going to be b over 2 plus 0 divided by 2, which is the same, and then b squared over 4 plus c plus 0 divided by 2. So that's just the midpoint. I forgot we got to put that over 2. So that's going to be b over 4 and b squared plus 4c over 8, I believe. Yeah. Okay. Make sure I did that right. And then the midpoint of RS, what's R and what's RS? Well, we actually just denoted them as that. Okay, that's it. So that's just going to be x1 plus x2 over 2, and then x1 squared plus x2 squared over 2. Well, this is where Vietas comes in. See, x1 plus x2 up here is b over 2. So this is going to be b over 2, which is b over 4. And this guy, hold on one second. Oh boy, this is not as straightforward here, so I've got to come up with a little bit of a algebra. x1 plus x2, let's see if I can get that expression, is x1 squared plus 2x1 x2 plus x2 squared. Okay, so that's x1 squared plus x2 squared. I got this, but then I got that plus 2x1 x2. Okay, that's where this comes in. So that's going to be, I got it. So this, according to Vietas, is b squared over 4. And then we have x1 squared plus x2 squared. And then this, according to Vietas, would be minus c. So if I isolate for x1 squared plus x2 squared, I get b squared over 4 plus c. And that's what I put here. But it's over 2, so it would be b squared plus 4c over 8. Okay. So this is the same as that. So same midpoints. That means they bisect each other. So we have proven that it's a parallelogram, and you can write that out in words. Okay. So now we got to concentrate on this guy, that at least one pair of adjacent sides that are perpendicular. Okay. That shouldn't be a problem. We use the slopes. The slope of V4S. So V4 was 0, 0, and S was what, x2 squared, I think. Okay, so the slope would be rise over run, so x2 squared minus 0, x2 minus 0, so this is just x2 actually. And then the slope of V4R, where R was x1 squared, that's going to be same kind of story. Sorry, x1 squared minus 0 over x1 minus 0. So that's just x1. Now, these two slopes, if they're indeed perpendicular, their product would be -1. So that means x1 times x2 would have to equal -1. Now, x1 times x2 is this guy. So that's minus c over 2. And therefore, c would be equal to 2. Okay, so that's my condition there. And, okay, so how many conditions do I have? I have this guy, this condition. C, this is from the previous question, actually, that c is greater than... And that c is not equal to 0. So we have to see if there's any other conditions. C equals 2, and then we have to figure out something for b. So if c is greater than minus b squared over 8, and c is 2, so that would mean 2 is greater than minus b squared over 8. So that means 16 is greater than minus b squared. That means b squared. This would flip actually. The b squared is greater than minus 16. Well, b squared will always be greater than minus 16 since b squared is a positive number. So that basically means for all b. So in conclusion, my 4 conditions are going to be that c is greater than minus b squared over 8. That's condition number 1. C cannot equal 0. C is equal to 2, and all b. So these are the 4 conditions to satisfy those requirements.